Hello everyone and welcome to our XAP 7.1 webinar and live demo. During this technical update and live demo, Uri Cohen, Gigaspace's product manager, will recap recent XAP releases and provide a detailed overview of the new Gigaspace's XAP 7.1. Please feel free to send us your questions during the webinar using the questions tool. We will respond to your questions during the webinar as well as at the end during the Q&A session. Also, during the webinar, you will be prompted with few polling questions. So once these questions come up, simply choose your response so we can learn from each other about our opinions and preferences. I wish you an enjoyable and interesting webinar and urge you to fill out our survey at the end of the webinar as your input is valuable to us. And now I'll pass the mic to Uri.
Thanks, Alit. Hi, everyone. Thanks again for attending. I want to do a short introduction of the agenda we're gonna have today. So the first thing I'll talk about is a bit about our vision, in general, and where the Gigaspace's product is headed, and how the recent releases are aligned with that direction. Then we'll have a short recap of the previous releases, namely Gigaspace's XAP 6.6 and Gigaspace's XAP 7.0. We'll then talk a bit about the 7.1 themes, and then we'll dive into the specific features that are part of this new version. We'll also demonstrate some of them. Hopefully that will work well. So I'm praying for the demo guys to be with me today. And then we'll talk about what's next in terms of releases, what's expected later this year in terms of versions, and what is the content of these versions. Naturally, at the end, we'll have a short summary and a question and answer session. So starting with our product vision and where we're headed. So before we go into that, I want to talk a little bit about some trends, both market trends and technology trends, if you will, that kind of drive the Gigaspace's product. So in terms of market trends, we're seeing some interesting developments in the requirements and the way people build applications. We're seeing a trend, the software as a service trend, as we call it. Google was the pioneer of that. Salesforce obviously was also the pioneer of that. But as we move forward, we see more and more ISVs move from the traditional software distribution model to the online software distribution model, namely software as a service. And that in itself presents new challenges to those companies in terms of scalability, throughput, and in general, the amount of operation of data that these applications need to handle. So we're talking about moving from one application per customer to one application per thousands of customers, and that's a totally different challenge. On the other hand, we're seeing a shift in the way people are using the web, what we call the social web movement. From a read-mostly experience, the web has become a read-write experience. Think of sites like Twitter, like Facebook. People are constantly sending information to those websites, and obviously that totally changes the way the back-end applications that need to store that information work. Then on the market trend. On the technology trend, we're seeing a few interesting developments. Actually, in terms of processing power, there's the Moore's law that says that every 2 years we have to double the processing capacity or the processing power of our CPUs. That in itself is no longer true. It manifests itself in a bit of a different way, in that we're seeing more and more cores on every machine. So this poses a different challenge to application developers, whereas in the past you could just buy new hardware and your application would usually run faster. Today you have to make sure that the application knows how to utilize this extra power and this parallelism that is needed to handle such environments. So that's regarding CPUs. Regarding memory and network, we're seeing a constant growth both in memory capacity and network latency latency y and bandwidth. Just a few numbers on that. Seeing 144 gigabyte machines that have 144 gigabyte of RAM is no longer something uncommon. We even have the Cisco Unified Computing System that can host up to 384 gigabytes of RAM within a single box. Obviously, that changes a few of the basic assumptions that we've had over the past couple of years. And naturally, with those changes, we can see that the current environments or the current architectures are not very well equipped or well designed to take advantage of them. So the thing we're trying to do with GigaSplices is basically bridge that gap by first of all providing a complete middleware stack that is distributed from the core, that does leverage those developments, namely the large memory density, the fast networks, and provides a full-blown middleware capabilities starting from the web interface of your application all the way to the data and messaging. A key aspect to that, of course, is simplicity. So naturally, if we were to take advantage of those capabilities, but this would be very complicated to use, we're only achieving part of the goal. And the main thing we're striving for is to enable a simpler way to deploy and manage applications in those distributed environments. So the end goal is to have an application that's deployed on 100 servers, make it as easy as deploying on a single server. And that's done through automation, of course, through the use of simple and, if possible, standard APIs. We'll talk about that a bit later in the presentation. Giving you the option to work and develop on frameworks that you know and love. So that's a bit on the vision. So enough with that now. I'll go into the technical details. A short recap on our previous releases. So about 2 years ago, we had released 6.6. I guess the main theme around that release was the completeness of our platform, whether it's API-wise, we call it reprocessing APIs, task execution, code execution over the grid, remoting support, web application support, asynchronous persistency to the database, interoperability with other languages. So I would say that version 6.6 has done some major leap in terms of the platform completeness. In version 7, we focused on two aspects, I would say. One is, in general, administration and how you interact with the running application. And, of course, a theme that's always recurring in our releases, and that's performance, mainly of the data grid and the core engine. So a bit on the administration monitoring functionality. We introduced in 7.0 the administration monitoring API, a very extensive API to both interact with the runtime cluster and get statistics on it. We've done some major overhaul to our user interface to be able to provide much more detailed and concise information on what you're seeing and how to monitor your applications. And we've done some nice improvements that help operational teams to manage and deploy GigaSpaces applications. So at this point, I'd like to hand it over back to Alit for a poll question.
Thanks, Uri. So just to help us a bit get to know you guys and understand where exactly you're at in your adoption of GigaSpaces app, please help us identify which GigaSpaces app version you're using right now, if any. All right. Okay. So I'm about to close the polls. If there's anyone else, okay, everyone voted. Wonderful. As you can see, we have most of the users using XAP 7, so you guys will be, I'm sure, interested to know what we have for you in 7.1. All right, Uri.
Okay, thanks, Alit. So what's in store for you guys in 7.1? So the first thing is what we call the elastic data grid. This is an initial phase of what we call the elastic deployment capabilities of GigaSpaces. The main motivation behind that is to simplify and automate the way applications are deployed and managed. In 7.1, this is going to be available as a technology preview for data grid deployments. We'll talk later about what's in store for future versions. The .NET administration monitoring API. So I mentioned before that one of the major things in version 7.0 was the introduction of that API in Java. And in 7.1, we've made sure that it is fully ported to our .NET edition. So now the power of this API is also available for .NET users. Some, of course, performance and footprint improvements. We'll cover those later in the presentation. Certification on more environments. So I'm not talking about operating system, but rather cloud and virtualization environments. We've done some nice work there. The basic idea behind this is, no matter what platform you're running on, GigaSpaces XAP will not force you to stick to a specific platform. On the API level, we've improved our querying support. We're now supporting more extensive querying functionalities. Of course, we'll cover that as well. And on the management front, administration front, we've introduced two interesting features. The first one is what we call the real-time troubleshooting capability. And this basically is designed to enable you to troubleshoot and to monitor a running system more easily, and a web-based dashboard. The web-based dashboard is, I would say, a first step towards a full-blown web-based UI, which we're going to introduce in future versions. So the first kind of preview or sneak preview to that is available in 7.1, and we'll see that in action today. All right. So speaking of the web-based dashboard, basically what it does at this point is it's a read-only dashboard. It doesn't support deployment or active interaction with the cluster. For that, you still have to use the swing-based user interface, the one you know from version 7.0 and version 6.6. What the web-based dashboard allows you to is monitor the state of the cluster, both in terms of physical machines and in terms of deployed processing units, reading like CPU, memory utilization, whether or not the processing unit is accurately provisioned and is functioning correctly in terms of the deployment. All of that stuff is available through that dashboard. Like I said, it's the first step towards a web-based UI, with the end goal of course, simplifying and easing the administration and monitoring tasks that you have to do on a day-by-day basis. Naturally, using a web-based interface doesn't force you to install GigaSpaces on the client machine. So if you want to monitor the cluster, you don't need to have anything but a web browser. Another aspect to that is that in many cases, when you want to monitor a running cluster, you do that from outside the environment that cluster is running on. So stuff like firewalls and DMZs and all that IT environments, anti-environment limitations are advent, and they make, of course, the communication between the client machine on which the GUI runs and the cluster a bit more problematic. So that causes a lot of errors and instabilities if you don't configure your firewall correctly. So the web-based UI is going to solve all of that, of course, because the web server is going to run side by side with the cluster in the same environment, and all you need to make sure is that you have actually a web access, like port 80 to that web server. So let's see how that works. Basically, let's open a web browser. Okay. So what you're seeing here is Google Chrome web browser, standard web browser. We're seeing the web-based UI. To start that, under the tools web UI directory within distribution, you have a bash script that starts it. We also provide this whole web UI is a standard Java EE web application, so we also provide the WAR file. You can deploy it to your own serverless container or even to the GigaSpace environment if that's something that you're interested in, for example, to achieve high availability of the server. And in this case, what we're seeing is we have two views. The first one is what we call host and JVMs views. And we can see that we have a moving graph that shows the CPU utilization and memory utilization of the entire cluster. We have the average view of all of the hosts in the cluster, and we have views of specific hosts and components. And naturally, I can choose what I want to display on the graph. I can unclick, for example, and remove and add things to the graph. You have here, of course, a grid that you can play with. You can sort. You can add and remove columns. And you can even filter, for example, show specific components or specific hosts. Okay, so everything is filterable. Naturally, this is, like I said, this is an initial implementation of what we're planning in the future. There's also what we call a processing unit view. So here the view is quite similar. Again, you have this grid that you can add and remove columns from. And you can sort that, and you can play with, of course, the column width. And you can also filter based on, for example, the processing unit name or the zone to which a processing unit belongs to. Basically, everything that is available in the grid can be used to filter those the content of that grid, the processing units. All right, so that's the web-based dashboard. Moving on to the next theme in the release, we're talking about the Elastic Data Grid. Like I said before, this is a technology preview at this point, which means that we've published that to as kind of a call for feedback. It's functional, it's working, you can play with it. The API is it's pretty final in that sense. However, we still consider that technology preview in the sense that we don't recommend that for production usage. And in terms of what it does, the main idea behind that is to simplify the whole process of deploying and managing your data grid. So what you need to do is you need to specify an acceptable SLA for your deployment. And when I say SLA, I'm not talking about low-level details like number of partitions and number of backups and these kinds of things. I'm talking about high-level requirements. For example, the capacity of the data grid, or how this deployment will be isolated from other deployments, when to scale up, what to do when the system needs to scale up. These kinds of things that are, really what you care about rather than the number of partitions. The motivation behind that, I think, it's pretty obvious. It's much easier to use. It will simplify the administration, and it will automate the way the data grid handles scaling up and scaling down. There's also another aspect to that, and that is cloud and virtualization environments, and I'll talk about that in a second. In terms of the API, you can see here that we're talking about an entity that's called the Elastic Service Manager. This is a component that runs on the GigaSpace's grid. When you kickstart a number of GigaSpace's agents, besides starting the GSNs and the GSCs, they will also kickstart this component and make sure it's running and it's available somewhere in the cluster. You get a reference to that using the admin API, and then you specify the deployment traits or the deployment requirements. In this case, we're seeing that we're deploying a data grid with an initial heap size of 1 gigabyte. We want it to be, with an initial Java heap size of 1 gigabyte. We want it to be highly available. We want it to have a capacity of up to 100 gigabytes. We want it to have a dedicated isolation. We'll talk about that in a second. And when the memory utilization, one of the nodes reaches 60%, we want the system to scale up and to basically shift or move some of the data to a new machine. That's the API. That's pretty much all there is to it. It's pretty simple. Some other things I want to mention here is that when the system does want to scale up, we provide hook points to that. Okay, so you can implement a certain interface and basically get a call, or the interface will get called when the system needs to scale up. And in this case, for example, if you're running on a cloud environment, what you can do is you can interact with the cloud API, start a new machine there, and then tell the system, okay, it's available, and the system is going to use that machine for the scaling up process. So the data that needs to be moved will be moved to this new instance. The way this works in detail is that the user deploys a data grid, of course, in that case, and specifies those requirements. And as you can see, we have a bunch of servers running. These servers are the servers that you want to have available for this deployment. And you can see that the servers are not running anything but the GigaSpaces agent. So for those of you that are not familiar with this, GigaSpaces agent is a very thin process manager that was created to facilitate exactly these scenarios and to ease the bootstrapping of the cluster. So when you start an agent, basically all you need to care about is that it's going to have the right services available somewhere in the cluster. So once you do that, the manager, the GSM in this case, will start the right amount of JVMs on those servers. Again, it will calculate automatically how many JVMs need to be started based on the JVM heap size parameter that you specify. And once it does so, it will deploy the data grid onto those JVMs. When you need to scale out, basically when the memory utilization, for example, reaches a certain threshold that you specify in the deployment, what's going to happen is that the hook point or the API that I mentioned before is going to get called, and once it does its work, the system is going to start more JVMs on the newly available resources and migrate part of the data to those JVMs. Naturally, there are more scenarios here to describe, but at this point, I'm going to move on to the next feature. And I invite you all to download 7.1 and play with this feature and give us your feedback. All right. One more thing we need to talk about regarding this feature. This is what we call the multi-tenancy mode. So multi-tenancy mode is basically the way your deployment is isolated from other deployments. So there are a bunch of modes here. The first and most simple mode is called a dedicated mode. And this mode basically, when you deploy a certain data grid, system is going to make sure that no other deployments are going to be deployed on the same host that your data grid runs on. Okay, so if your data grid runs on, say, 4 hosts, these hosts are going to remain dedicated to your data grid. The other two isolation levels or two multi-tenancy modes are shared modes. And this means that the system is going to allow for other deployments to run on the same host. The shared private mode will only allow for deployments of the same user or the same tenant to run on the same host. The shared public mode will allow for any deployment, regardless of the tenant or the user, to run on the shared host. So again, you have the flexibility here to determine which service level is most fitting for your application. So for example, for very mission critical and demanding application, you might want to choose a dedicated mode. But for batch applications or applications that run in the background, you may want to sell it for one of the shared modes. All right, so that was the Elastic Data Grid. Moving on to the next one. This is improved querying support. The main thing here is the ability to navigate an object graph using the query language. So for example, if you have a user object, that has a first name, a last name, and an address object, which is an internal object, you may want to query, for example, on the street name or on the house number. So the thing we did in 7.1 is to allow our users to query on those properties. Now, the first thing you have to do, of course, if you want the query to run with a reasonable performance, is to index those properties. And knowing that those embedded objects, like for example the address object here, may be used in other classes, we've decided to include the indexes for those properties in the containing object. And you can see here that we index two properties of the address object. One is the street and the other is the zip code. And we're using a path expression in this case to annotate for the system what those properties are. We can also specify the type of the index. For example, we can use a basic index, which is an index that's fitting for mainly for equality expressions. It doesn't have an order to it. So if you are looking to do a greater than and less than query, you should use the extended index. The way to query these properties is very, very simple. It's much the same way you're used to from the previous releases, only now you can actually specify this dot notation and interact with inner properties of your objects within the query. In this case, we're querying for all the users that live in Baker Street, whose zip code is 12334, and we're using the read multiple method to get all the persons that match this query. All right, so that was on improved querying support. Next one is distributed troubleshooting and log gathering. What this is all about is basically the ability to give you better visibility into what's going on in the cluster at runtime. This is mainly used when something bad happens, and you want to have more visibility into that. So the first thing we've enabled is a log view from within the user interface. You no longer need to log in to the machines. Naturally, you can have a large cluster, like 20, 30, 50 machines, and logging into each one of them is not a very pleasant task. So we've enabled the log view directly from the user interface. We'll see that in a second. And the second one, maybe the more important feature, is what we call a system-wide snapshot. And a system-wide snapshot is an ability to, at the click of a button, gather the state of all the running services within the cluster. And when I say state, I mean heap dump, thread dump, all the logs that have been printed out in those services, what is deployed on those services, what's the status of these deployments, et cetera, et cetera. So once you do that, basically, the system will gather all those logs for you and let you use them. So let's see how that works. So what I have here is a very basic deployment. It's running on my local machine. We're seeing here a bunch of running services. We're seeing a GSC and a GSM and a GSA. And note that if I click one of these, I immediately see a log view of this process. And this is actually a tail view, so everything that's going to get printed is going to get propagated on the fly or at runtime to this screen here. Actually, I can filter using a regex. So, for example, if I want all the info messages that were printed in that log, I will get those messages. And what this does, actually, it goes all the way to the GSC and and instructs it to filter out those log messages. In terms of performance, by the way, if there is an agent, a Gigaspace agent that's present on the machine on which the GSC runs, the agent is going to be used rather than the GSC itself to impose a minimal overhead on the runtime environment. In terms of log and dump generation, which is the second feature I talked about, the way this works is by simply right-clicking the component, you can actually instruct it to generate a dump. And more interestingly, you can do that for all the services that are running on a certain host. or for all the services that are running within your cluster. So this is what we're going to do now. Once I do that, I have a dialog here that asks me for what we call a dumped zip file location. This is actually the zip file that's going to accumulate or gather all of those reports or all these status reports for the cluster. In this case, we're just going to call it, we're going to put it somewhere here. Yeah, that's fine. We'll call it dump.zip. And you can also specify a reason for retrieval, or just say test in this case, or even demo. And you can choose which type of dump you want to include in this zip file. In our case, you can specify JVM thread dump, network dump, which is a summary of all network operations, a log dump, which is all the logs that those services are generating, a processing unit dump, and if you want even a JVM heap dump, this is not available by default. This is not marked by default because this imposes quite some overhead on the JVM. So we only want you to use it when you have to. Let's generate this dump file here. All right, it's been generated and downloaded successfully to the client. And we'll go to the file browser now. And basically, we'll see this dump file here. Let's open it. And we can see that for each of those running services, we basically have a subfolder within the zip file. And when I further dive into this folder, for example, I can see summary report on the JVM, for example, system properties, JVM parameters. I can see a thread dump, complete thread dump of this JVM. For example, if you have a deadlock, this is a very convenient way of finding that out. We can see a status report on the processing unit instances that we're running on these services. You can see the PUXML itself, a report for the space, how many instances, how many entries, how many templates, what's the space URL, et cetera, et cetera. So this is a very handy feature when you are running into issues and want to take a snapshot without having to do that manually and logging into each of those machines. The nice thing about this is that it's also exposed via the admin API. So that means that all the stuff that I've just shown is also can also be implemented in code. So for example, you can tail the log in a distributed manner, and you can see here that the API is pretty rich. You can use a bunch of what we call log entry matchers that have regular expressions, the last n log messages, and even what we call a continuous log matcher that only brings you the latest messages within the log. And basically, once you do that, for example, you can only filter, let's say, the error messages that are emitted from those logs. And when such an error message is emitted from one of the members of the cluster, you can actually use the dump functionality to take a snapshot and send it automatically to the administrator or even to the Gigaspaces support team. So again, the same power that you saw within the UI, you can automate that and use that within your IT environment. All right, so that was distributed log and dump generation. A bit about the .NET Administration Monitoring API. Basically, that brings the full functionality of our admin API, our Java admin API to .NET users. I think the motivation behind that is pretty clear. A lot of our .NET customers have been asking for that. Naturally, they could implement monitoring and dynamic behaviors on top of our Java APIs, even if they did use the .NET environment. But naturally, this is much more intuitive and natural for them to use .NET. So here's a short snippet of what that would look like. So in this case, what we do is we actually annotate that a second. We actually here create what we call an admin instance. And this admin instance, in turn, what we do is we get all the processing units that are running in our cluster. We print the processing units' names, and then we iterate the processing unit instances and print some details on those instances. Okay, so this is just a very simple example on what you can do. Naturally, you can also interact with the cluster, deploy, undeploy, start and stop JVMs, and everything that's available in the Java API. All right, a bit about transaction and performance improvements in this release. So in version 7, we focused mainly around read scenarios and our local cache performance. In this release, we have chosen to focus on our transaction concurrency performance, and I'm talking about highly multi-threaded, multi-core scenarios in which you do a lot of transactions, and those transactions update a lot of data. So what we've done is we've made sure that the contention around those areas would be minimal. That in turn also helped us reduce some of the footprint associated with our indexing mechanisms. So there's also some nice improvements there. In terms of numbers, this is most evident obviously when the environment is isolated and there are no other factors involved. So in this case, this shows the performance improvements in a single space, naturally with no backups. So for most purposes, this would not be very practical, but it just shows the amount of improvement that was done. We can see that the differences between 7.0 and 7.1 are pretty significant. For 4 threads, it's more than 2 times faster. We're talking about 220,000 transactions per second. Each transaction, of course, contains about 10 destructive operations like write, take, and update. And you can see that it's very evident the more threads you use. So in this case, we had a dual quad-core machines, so we chose to 8 threads would be kind of the limit because that shows it's CPU bound. And you can see that the improvement is even larger here. It's almost 4 times the performance in 7.0. When you put that on a remote scenario, naturally the differences are kind of they're not as impressive as with embedded scenarios because we have the network overhead that masks a lot of the improvement, but still we see a very nice improvement of between 15 to 20% between 7.1 and 7.0. All right, a few words on certified environments. So like I said before, we were mainly talking about cloud and virtualization environments. Over the past year or so, we've done some very extensive work with those environments. We're talking about our integration with Amazon EC2, the GoGrid Cloud, the Rackspace Cloud, and naturally VMware, the ability to run on VMware ESX servers, and to make sure the system is flawlessly behaving on those environments. So basically, the main motivation here is to make sure that no matter what is your preferred runtime environment, gigaspaces will not be the limiting factor here. If you want to run on your dedicated IT infrastructure, that's fine. If you want to run on the cloud, that's also fine, and we give you all the flexibility of choosing the right environment for you. Another interesting integration piece or certification piece that we've done, actually there was something that we've done in the last couple of months, is integrating with the Cisco Unified Computing System. A few words about that. Cisco Unified Computing System is a hardware architecture around Cisco's components that enables a number of what we call groundbreaking capabilities. One of them is what Cisco calls the ultra-fast network fabric, and that's basically the ability to, for example, to associate specific cores with certain network interfaces, and to make sure that network utilization across your racks or your data center is optimal. Another even more impressive aspect of that is the support for a high memory density. So I mentioned that before. You can have up to 384 gigabytes of RAM on a single blade. That means that across the cluster you can have terabytes of RAM, and you can see, of course, the implication of that for platforms like Gigaspaces. An interesting thing we saw there is that you are able to run very large Java heaps, and I'm talking about hundreds of gigabytes on this environment with very minimal effect. And this was it surprised even us in terms of what we can do there. If you want more details on that, naturally, please just log on to our website, gigaspaces.com/Cisco. You can see there all the benchmarks and understand better what we've done in terms of certification. All right, so at this point, I'd like to hand it over to Alit again for a poll question.
So let me just launch our second poll here. And after you heard all about our latest features in XAP 7.1, please tell us, what is it for you the most important aspect in Gigaspaces XAP? All right. Come on. Those who didn't vote yet, I'm just about to close the polls. All right. So let's see all of us together what we have here. So it appears that 40% chose performance and scalability. Next in line was ease of use, and the third one was the standard APIs. Thank you very much, everyone. Uri, please, you can continue.
All right, thanks, Alit. Thank you guys for sharing that valuable information with us. So a few words about what we expect next. The second release this year, 2010, is 8.0, and this release is going to be around simplicity and standardization of APIs, and further simplifying, the elastic data grid deployment. In terms of standard APIs, we're talking most notably about JPA, Java Persistency API. The ability to interact with the space via JPA, write and read data from it using JPA, and use the powerful query language, for example, that this specification provides. We're also talking about document-based API, basically the ability to introduce into the space more free-form data types than strict Java classes, and we intend to expose that API via REST as well. And the last one is Memcached. In terms of the elastic deployment, like I said, in 7.1 we have the data grid technology preview deployment, and 8.0 this is going to be a fully GA production-ready functionality that's going to enable to deploy anything from a data grid to a processing unit to a web application. As for the web-based UI, we're talking about a full replacement for the current Swing user interface, and that's again expected in 8.0. You'll be able to do all the stuff you do today. And right now we're working very hard on finding the right concepts and designing the UI that would make most sense to our users. The last bit is what we call automatic disk overflow, and this is the ability for the data, for example, to transparently overflow to the disk if the capacity of the space is exceeded. This would give our customers, we think, much more flexibility and resiliency in scenarios where the capacity planning wasn't done correctly, or there's an unexpected surge of data in the system. So that's 8.0. To summarize, so again, we covered a lot of features just to make sure how these relate to the overall concept of the system. So again, we focus on those three aspects: the development, naturally, introduction of easier to use APIs like the querying, the Elastic Data Grid API, the deployment facilitation through automation, provisioning, and simpler configuration, and of course the management aspects, which we saw, like the cluster-wide dump and log generation, and the web-based console dashboard. So, first of all, thank you guys for sticking up with me for so long. At this point, I'd like to open the floor for questions.
Okay, so thanks a lot, Uri. And we do have some time for Q&A, and we have some questions that we already got, and people feel free to continue sending us your questions. So one of the questions that we got was, can you be more specific about your plans regarding JPA?
Yeah, sure. Thanks, Ali. That's a good question. So JPA, as you probably know, is a very extensive specification. First of all, in terms of course, motivation, it is, I guess, the data access API in enterprise Java, and Java in general, I think. So it makes for us a lot of sense to support that API. As a first phase, what we're going to do is we're going to support the JPA API on top of the space, namely, the querying functionality, the annotations, the transaction scoping, and all this good stuff that comes with JPA. As a second stage, what we're going to do is we're going to make JPA what we call, I would say, a first-class citizen within the platform. So that means that you won't only be able to interact with the space, like read and write data to and from the space, but even use the existing SBA, space-based architecture constructs, like polling containers and notify containers and event processors using JPA, for example. So if you have a polling container that needs to react or process data as it flows into the space, one thing you would be able to do is, for example, specify a template or a criteria for that polling container using JPA query. And all those features that will be available for JPA will also become available at the space API level. So naturally, all the good stuff that we provide for JPA, like transaction scoping, for example, is going to be available using our native space API.
So we have one more. This one asks, what is the performance impact of the replication queue flush to disk?
All right. So that's something we discussed briefly. Basically, this one is a functionality that I mentioned that as part of 8.0. We also have that initially in 7.0, and our replication queue is basically the mechanism that enables you to enables the space to replicate data to the backups and the mirror services that are running in the cluster. And the way this works is that all the changes, usually if you're using synchronous replication, for example, this queue will remain empty, but when, for example, a backup fails, this queue will start to fill up, and once the backup comes back up again, this queue will get flushed onto the backup to make sure that it's synchronized with the space. So in 7.1, this queue basically is when it reaches a certain capacity, it's automatically and transparently flushed or swapped to the disk to make sure that the memory utilization doesn't exceed a predefined threshold. In terms of performance impact, I would say that it's pretty negligible because most of the time you will not feel that. Once this queue kind of brought up to memory again, I would expect it to be a small hiccup, but it's nothing more than that.
That we got here about performance is, what is the performance impact of running XAP on VMware?
All right, that's an interesting one. So it really depends on what type of topology you're using and what type of hardware, of course, is available. I wouldn't say there's no impact. There is an impact, even a quite substantial one. That can be a factor of 2 or 3 even. The main reason for that is the replication to the backup and to the mirror services, and the fact that VMware by default uses what we call a virtual switch, which in itself uses the CPU, the same CPU that your application uses. So that can slow down things a bit in terms of the way the network behaves. If you're talking about, for example, pure in-memory processing, like, for example, read-only transactions, the performance of that, the effect of that would be, 5 to 10%, something like that, nothing more. Interestingly enough, when you go to environments like Cisco UCS, which have specific optimizations for VMware, and they can actually couple a VMware virtual machine with a specific network interface, this overhead is significantly reduced. So instead of having an overhead of maybe 2 times more than running on a dedicated hardware, you would have 10 or 15% overhead, which is I think quite impressive.
I think this was the last question we just received. So at this point, I'd like to thank you, Uri, and the audience. And we're going to end our webinar. We would appreciate it, again, if you can please fill out our survey. And please note that in a few days, we will send you a link to the recorded webinar as well as to the Q&A. Thank you very much, and have a great day.